Okay, so today we're going to do implicit differentiation. All it is taking derivatives of relations. We've been doing derivatives of functions. So a function or explicit form is when we have like a y equals. So like y equals anything is explicit form with no y's on the other side. Because if you can graph it on your calculator, it's a function. I don't know, give me your favorite function. I don't care. X. Sure, x. That was really brilliant. What's another example of an explicit form? X squared. Okay. Alright. We can take those derivatives pretty easily. So implicit, that's when this is not a function. Typically that means there's multiple y's or the y is nested inside of some type of function itself, such as y squared equals x. That is not a function. So we have to do implicit differentiation. Can you think of your own non-example? Or sorry, example of implicit, which is not an example of a function? Who just said y cubed? Come on, it's better than that. Nobody? I got one. Ready? Sine of x plus y equals 1. Ooh. This would require implicit differentiation because the y is not isolated. Now, sometimes you could isolate the y and it might totally work. This one might actually be that case. You could probably isolate this y if you had to, but let's just move on. Okay, if a function cannot be written explicitly, so it means you cannot express y as a function, then you must use implicit differentiation to find the derivative. So, let's practice doing implicit stuff with respect to x. So here's the key. That's really stupid. I hate the notes. One of these days I'll stop complaining and just actually do something about it. Until then. So what that means is we have to write down what the derivative with respect to x is. Now we've been doing that for a while. That's not a big deal. What's the derivative of x? We've been doing that for a while. Not a big deal. We have actually been doing the derivative of y too. When we do the derivative of y, how would we write it? We write y prime, which is actually a notation of just dy dx. So every time you write down a y, or take a derivative of a y, we call this tagging. You're going to tag every time you take the derivative of a y with dy dx. Okay? Let's just move on down to 4. I don't know why 3's there. It's kind of stupid. So what's the derivative of y cubed? Well, if this was x cubed, how would you do it? It would be 3x squared. Same idea here. So what's the derivative of y cubed? Three y squared, but you have to tag it. Okay? Every time you take the derivative of a y, you have to tag it. Chain rule. It's because of chain rule every single time. Because, for instance, we take the derivative of x, it's 1 times chain rule. Wouldn't that just be dx over dx, which is equal to 1? So every time we take the derivative of x, we've always imagined it being dx over dx. We don't write that, though. So every time we take the derivative of a y, it's going to be dy dx. Or, it depends what it's respect to. Sometimes we'll do respect to t, time, in which case everything gets tagged, except for the t's. Alright, so, for instance, number 5 here. Let's go ahead and take the derivative with respect to x. What's the derivative of the first one? Plus, what's the derivative of the second one? 3. Yeah, I gotta tag it. Number 6. A lot of people get this one wrong. All the time. I see it all the time. I tutor kids, and then they'll get this one wrong. And then they'll fire me, and I'm like, why? It's a joke. I've never been... That's not true. No. I'm not tutoring this one kid anymore because his grades are too high. I'm that serious. Well, his grades are pretty high. I don't think we need you anymore. I'm like, oh, okay. I hope your grades plummet. Anyway, let's move on to number 6. So, x times y squared. What kind of rule is that? It's product rule. Awesome. So what's the derivative of the first? It's 1 times y squared plus the first. What's the derivative of the second? It's 2y. dy dx. Got to tag it. Okay, I want to do just one extra one. Let's say that I want to do d over dt because I was talking about that. I'm going to do just like the example just above it. This marker's kind of running out. So what if I did d over dt? What would the derivative of x be? dx over dt. It'd be 1 times, got to tag it because it's a different variable in the bottom. So it's going to be dx over dt plus derivative of 3y is just, do we have to tag it? Y. Just got to be careful with stuff like that. Alright? Actually, we don't really use t's until like late November. That really bugs me, but I got problems with the notes and the order of the notes. Alright, well, let's do these 2 problems and we're done. Alright, there's 4 steps. That's it. But this does require some heavy lifting with algebra. You have to know how algebra works and be good at algebra. So let's go ahead and go through this. So, here are the steps. You can follow them along if you want. I'm not going to write F and we just go for it. Because step 1 is to do calculus and step 2 is algebra. Alright, you all should know how to do algebra. So step 1, find dy dx. So we're going to take the derivative of all of this. So what's the derivative of the first term? 3x squared plus dy over dx minus equals, what's the derivative of 9? 0. I cannot tell you how many kids will mess this up. They'll just put equals 9. They'll forget about taking the derivative of that. It equals 0. That is a common mistake. For implicit, the 2 most common mistakes are forgetting to do product rule and derivatives of constants are zeros. We good over there? Okay. We need to solve for dy over dx. Let's just do this like we would back in algebra class. You need to get the dy dx terms by themselves. Take out a GCF dy dx and divide everything else over. Boom. Done. Let's do it. So let's get the dy dx terms all by themselves. So what does not belong on the left-hand side? So we got to get rid of them. So it becomes 4y cubed dy over dx minus 2y dy over dx equals negative 3x squared. Okay, what's the GCF on the left? Now, I only care about the dy dx GCF, so I kind of just answered your question. Do not take out the y as well. It's not, you're going to have a bad time. Don't do that. So only take out the dy dx. So on the left-hand side, when I take out the dy dx, what's left? What's that, class? 4y cubed minus 2y? Wow, we're really good at algebra. And to get this bad boy by itself, all I need to do is divide. So dy over dx is equal to negative 3x squared all over 4y cubed minus 2y. And that's it. Now, sometimes they'll ask you for the slope. All you do is just plug in the appropriate points and get the slope. Sometimes they'll ask you for the second derivative. From here, you just do the second derivative. And we'll do an example like that. But that's about it. Again, people mess up here, mess up with the product rule, and then if anything else they mess up on is just algebra. Do you want to try 2 on your own?
Yeah.
Sure. Go for it. I'll give you a minute, then I'll do the first step just to make sure you're doing it right. And if you're watching the video, you should try it too. Oh, and Daniel, if you're listening to this, I was just joking. I hope your grades are fine. There's a lot of Daniels. I could have just picked Bob. Or Joe. Or we have 2 Jasons. I could have picked a Jason. Actually, there was another time I never got called back again. It's because I was in charge of NHS, and these 2 girls who I tutored, they skipped out on the NHS project. So I called them out on it. I never got hired again from them. I should have never. I should have just let them go. Yeah, we actually do NHS in Highland Park. We kick a lot of people out. Well, because people don't, like, especially NHS, people don't really know what NHS is. They're like, oh, it's just supposed to be just an honor thing. Well, not in NHS. You're actually supposed to, like, help the community. That's the purpose of it. That's part of the 5 pillars. One of them is service, and people hate that one. Highland Park, they get kicked out because they don't do the service one. They have to do 7 hours. I give them 15 weeks to do 7 hours. They could do it for each semester. So they have it half an hour a week. That's all you need to do. And then the football players are like, we just had no time to do it. No, you didn't. Practice ended at 6. So Boys and Girls Club closes at 8. And then their moms would email me. My son, Daniel, everyone's Daniel, he's perfect. He just had no time to do it. I'm like, yeah, well, seeing that you're emailing for him, he probably shouldn't be in NHS in the first place. I never would say that. I would just say, yep, so sorry, this is our policy. No one, I've seen the views. No one listens to these things. How do we do on the first step? This was not hard. I did that. How many Y's are there? Give me just one of them. Yeah, when I do product rule for the first part, I'm not doing the derivative of Y in the first part of the product rule, so I don't need it. What's up?
Yeah, so does the 25 not mean anything like this?
It just goes away. What's the derivative of 25? 0. Goes away. Ooh, look at that stuff. Any questions, comments, concerns? I do have more to talk about with this implicit stuff. I want to make sure you have a deeper understanding of it. Now, this problem number 2 did not require implicit. What could I have done to prevent implicit? I could solve for y. I could solve for y equals. Couldn't I do y equals 25 minus 3x all over x squared? Good quotient rule. And got something very similar to this as an answer. Why would this answer not match the one I get from here right off the bat? Because there's a y here. But couldn't I always substitute this y out for that? And then it would match. Hey, there's one more problem I want to do, because like, it's super important. These notes leave off lots of things. Alright, so I gotta do this really important problem. Write it down. Alright, let's go through this one together. The first part isn't that bad, but it's going to have to involve taking a second derivative. So that gets a little dicey because it usually requires quotient rule, and people get really nervous about that. And then you're going to have fractions instead of fractions, and that makes people really, really nervous. Then I say to them, it's just algebra. Come on, people. This only requires 2 steps of calculus. That's it. The rest of it's algebra. Calculus is not hard. Algebra must be. So, which derivative of this going all the way through? 8x minus 4y dy dx equals 0. So what is dy dx? Can I do this in one step, or does that scare you? You subtract an 8x and divide by a negative 4. Doesn't that equal 2x over y? Yeah. Good enough, but it would have been product right here. It would get very messy. I like your thought process of trying to create shortcuts. Doesn't work. And the reason is because you cannot have dy dx in your answer. So I mean, you have to solve for it anyway. All right. Are we done talking over there in the corner? I guess it applies to all corners. The back corner. Inner corner. There's too many corners. There's 1, 2, 3, 4, 5, 6, 7, 8 corners. Neelish corner's never talking. Who would talk to Neelish? No comeback, Neelish? Alright. You're more than welcome to start throwing them back at me. Was that a Because that's how I took it. Was that your intent, or was that a coincidence? Alright. Hilarious. Neelish, you look lost, and that's a good thing. Alright, let's move on. Neelish, if I did not like you, I wouldn't pick on you. Jonah's like, doesn't pick on me at all. Nah, there's no one here I dislike. I was going to say don't not like. There's no one I dislike. I like all of you. You're all fair game. Okay, so take the second derivative of this. So the second derivative of dy dx is just going to be, it's just d squared y over dx squared. It just means the second derivative with respect to x for the second time. Okay, this is product rule. So what's the derivative of the top? Leave the bottom alone. Minus top. Derivative of the bottom. All over. Okay, you're not allowed to have dy dx in your answer, so you actually have to substitute that in. So doesn't that give me a 2y minus 4x squared over y? Am I allowed to have a fraction and fraction? No. Alright, so how do I get rid of that y? There's actually a couple of different ways to do it. I'm just curious how you were taught to do it. How would you get rid of that y? No. Okay, so you're doing the slow way. That's okay. I mean, I don't know. It depends what your teachers teach. I teach it like the fast way, and everyone gets really confused by it. They're like, "Whoa, what just happened?" The fast way is whatever the denominator is in that fraction, multiply every single term by it, and then boom, it goes away. Yeah, you're saying make a common denominator, which is fine. It just has an extra step in between. So if I multiply absolutely everything by y, is this legal? That's totally legal. So when I do that, what do I get? Okay, now here's the really, really like tough part about. Here's the tough part about these problems. The second derivative ones is I can guarantee you there will not be an answer choice like this. I can guarantee it. This is the correct answer. I want you to figure it out. Why is that the correct answer? Someone figured it out. Someone went, oh. What is it, Mason?
4x squared minus 2y squared equals 9. That's their thing. But it's negative on the top.
For second derivatives, typically the original function magically appears. I don't know why that is. It just does. So then all you need to do is substitution. So just kind of be aware of that. That is so awesome and amazing. Love calculus. And let's just do one more little baby example. Okay, one more time here. So all I'm going to do is substitute this in for here. This is just the opposite order. So you got to change the signs around. So if you were to negate this, negative x squared plus the 2y squared minus the 9, then it'll be an easy direct substitution. Just kind of be aware of that. Okay. Last example is find let's see here, 1/3. All right. Finding the derivative with respect to t, that means time. of this. What shape is this? It's a cone. This is the volume of a cone. So we're going to find what the rate of change of the volume of a cone is. This is exciting. You ready? We're getting to like real life applications of calculus. Getting there, and then we're going to slow down and do nothing like that. And then we'll get back to this. Anyway, so what's the derivative of v with respect to t? It's just dv dt. Equals. Do you get this as product rule right there? Let's just keep this 1/3 pi by itself. Let's do the product rule inside this parentheses. What's the derivative of the first? dr over dt times h plus r squared I'll kind of just leave it at that. I'm not going to simplify any further. We'll be doing problems like this. Should be soon, but it'll be like in a month. Where we have to find the rate of change and stuff, and it's really not that bad. Just as long as you know how to take derivatives implicitly, you'll be fine. Alright, we feel good about implicit?